Hi, it's Terry Dennery of the MathWorks. Anyways, this video originally was going to be titled Switching Your Motor Type. And the basic idea was go from a DC motor to a permanent magnet synchronous motor, which is going to employ field-oriented control, right? And, it turns out I built a model that does that. And I really like the model quite a bit. So I want to kind of share it with you right now, right? And so let's bring up this scope. Okay, you can see it running. All right, and we're essentially commanding something similar to what we've been doing with our position control of the DC motor shaft. All right, and then we're going to transition it from one state to another state. But in this case, it's angular velocity, and we're going from 0 to 10 rotations per second. So it's moving pretty fast. And all I can say is I just kind of love looking at these AC waveforms for both voltage and current. And the what's taking place with a permanent magnet synchronous motor is that there are 3 voltage terminals, um, and they essentially control the magnetic field at certain spaces. And you get into a little bit of a conversation on what pole pairs mean and stuff like that. But from an electrical point of view, and if you could kind of come up with this idea of 0 to 2 pi or 0 to 360, you can see that the waveforms are essentially spaced, let's say 120 degrees apart from each other. Anyways, it's a very cool topic, and I might get into it in the next video where I'm going to get very specific about this. But I think I'll show you kind of what happened. All right. And so let's copy this. All right. And I go, well, DC motor, AC motor. All right. Go into my plant. There's my DC motor. That's essentially the thing I want to replace. All right. And I thought, okay, just send in the right torque. Oh, wait. I'm not receiving torque at this level. I'm receiving voltage. Okay. And so what I realized was that to kind of bring this in, that I need to accommodate its interfaces. And again, it kind of gets into this idea of standards, but maybe even the bigger topic is how do you kind of accommodate the specialists, the people who really understand AC motors and field oriented control and all that kind of stuff. And so it's really kind of this idea, and so the new name ended up being sourcing and what I call it, and distribution, but it's essentially accommodating, kind of like, component vendors, and just kind of accept that these people are magic and that they do these magic things, and that if I ask for a certain torque, it's going to deliver it. Yeah. Anyways, but let's kind of recognize the main um, interface is it wants torque, and it needs feedback on angle and angular velocity, and it will deliver electromagnetic torque, which is good because that's kind of what we have right here. But the torque command is really taking place elsewhere. And so I'm just going to come up here. Actually, I'm going to go ahead and delete that right now, just kind of make it clear that this demo is not about replacing the motor. It's about setting up the platform so that we can replace components, all right? And so anyways, I am going to go into the controller first, right? And the controller, you can see, has kind of the output of V and motion command. Okay, and so I keep that motion command, at least for now, but I do want to replace that output, right? And that what I want to call it is T sub E, maybe I'll throw in Newton meters too, right? And what I realize is that that's what's coming out right there, right? So in a way, most of my work's done for me, right? And what I'm gonna do is hit Control X to delete that, just delete that, and I don't need to get my torque information from this bus anymore. All I need is that angle, okay? And so I'll call it my new top level controller, just looks like this. And if you really look at it, you see that this is your mechanical controller. And because it's at the top level, it's what we would call the outer loop, all right? So now let's go in and accommodate that, all right? And So first thing I'm going to do is I'm going to paste in that thing that I controlled X'd. All right, so that's essentially my current controller, which is my inner loop. All right, and so let's bring this up here. Let's delete that line. Okay, and electromagnetic torque is calculated at this level, and we can just pop it in right there. So I believe I made no real structural, well, let's say calculation change, right? But it's always a good idea to check that, right? And so let's go in here and let's hit run. Okay, so it's taking some time to compile. And I did a rehearsal on this and I saw that same thing take place. And I'm not exactly sure what's going on, but I'm going to blame it on the fact that we're making a recording and somehow there's a little bit of something going on there. But anyways, I think we're going to need to wait. So let's let it compile. There we go. Good. All right, so that's good. So basically our command signal and our response are perfectly aligned and therefore things are working beautifully still, right? But you can see that this is TE coming out. I'm happy where this is right now, but you know, that is not V that we're sending in anymore, right? So we'll go in here and we'll change that to T. Maybe I'll call it E, you know, whatever. Different groups have different notations. The next thing I want to do is, again, some reorganization, right? And so I'm going to take all this right now and I'm going to create a subsystem out of it. And this now is called my motor drive. And the name, at least as I'm intending, is to really account for both control and you know, device are all represented inside the same subsystem. All right, so it's called the motor drive. Now I'm not happy with like all the lines and the interfacing and stuff like that, and so we're going to fix that a little bit right now too. Okay, and there's something about our classic form that I really want to kind of point out because I think we're kind of hitting it again, but we're going to amend it slightly. And the amendment is the fact that, well, yes, absolutely, a motor is, you know, where you're controlling voltage to get the current that generates the torque that will make your system move the way you want it to. You know, it's assuming essentially the role of a component, and it's a component within a system, and therefore it needs to be informed on what's happening in the system, and it also needs to reveal, you know, its information, and I'll be very precise, its operational state, which you could say is kind of captured by those outputs we see for this right now. Let me kind of bring these in just so I can hit the space bar and things can be big. And yeah, there's more than just these ones, but we'll kind of go with this for right now. And so it's state, and there will be more, will be torque and current. Okay, and okay, so anyways, let's kind of work on this part first. So Control I, okay, and I know that this is essentially W. No, it's not. No, it is not. Actually, this is the easy one. You know, that this is TE. Well, TE is calculated right there. So I can get rid of a external reference completely on torque. And so let's just take this, right mouse click, allows me to pick off that signal. Okay, now this is the one that is an external calculation. All right, and I understand that a lot of electrical engineers will contest this and say, hey, we understand velocity real well. And certainly they do. It's a big part of how you develop controls for an electric motor. But I'd say that in general, the mechanics of whatever we're connecting this to will be far more complex than a mechanical shaft. And as you get into like robotics and you know just mechanical applications in general, I think it's reasonable to assert the idea that this is the domain of the mechanical engineers, and therefore this information should be received kind of from the overall system, right? And so anyways, I'm not going to delete the input block itself, but I am going to begin by renaming it, right? And I'm going to put it right down here too. Let's hit the space bar just so things show up good again, right? And so let's rename it, and I'm going to call it sys. What do I want to call it? I'm going to call it M. You know, I've been using M as a measurement thing, and that this is going to be coming from a bus. All right. Okay, so this bus is not connected yet, and therefore it's sort of like, I don't know what you're talking about. Okay, so let's go back up here, right? And I'm going to delete all this. Okay, and of course, we've already been doing this. All right, and so I'm going to just go here, and this is essentially that bus we created a couple of videos back, and we know that angular velocity is on it, so we're going to have what we need for this. All right, and so now I can double click on this block, and I can see what I want. All right, and so select angular velocity, remove those. Okay, and now I can send that right in like that. Okay, and last I want to, well, get rid of 2 completely, and 1 I'm going to rename that too. Okay, so we still got kind of the internal reference kind of going on that feedback loop, but let's report our information. All right, and so now I'll go get a bus creator. And fortunate for us, all these things are already named, and so I'll just go in there and get current, and then I'll send torque in. And I think things are pretty close to where we need them to be. Oops, I didn't rename that yet. All right, and so I'll call it motor state. Okay. And therefore, this last piece I need to do is go receive that information. Again, with the bus selector. Moving it closer just so when I hit the space bar, and this will be a good thing to do too, everything's bigger. We can kind of see that, right? And signal 1, that's not what I want. So let's go in here, right? I'm not exactly sure why we set this one up the way we do, but let's just go get both signals and select. And certainly it's a good thing that it gives us the names of what these signals are coming out, right? And so we're going to, again, just kind of pass that information along for current, because somebody will care about it at some level, right? And I think we kind of got it. Let's go ahead and, again, kind of verify, and we'll hit run. It might take a little bit of time for this to run again, so let's just be patient with that. Okay, and so did that run? Oh no, it's still compiling. So we're still looking at the last simulation results. So watch the green line right here. And as long as I didn't make any mistakes, because in practice and rehearsal, it did work pretty well. But got a little bit of time to talk right now, and so although I'm distracted as I watch, that in conclusion, I think we have it set up now so that we can bring in our permanent magnet synchronous motor, apply field-oriented control, and it will just work. And the more general kind of wrap up on this video, I think we've set up our platform such that the real specialists can kind of come in and do what they need to do. Okay, and in this case, we're accommodating those who really understand permanent magnet synchronous motors where field-oriented control is applied. And big thing for systems people is this sort of thing. Do this last piece. Let's name that. Just be quick. T. Okay, is that we have set up the interfaces so that folks can kind of come in and do what they need to do. Integrate into the system information definition, and then accommodate the information that will be required, of their component. And in a way, and this is kind of a good thing. It's when you become a motor, or let's say if I am a motor, if a motor could be a person, it's kind of showing that I don't really care what I'm connected to. That all I need to do is kind of deliver on the torque's been asked of me and then integrate into the system. All right, thank you.